Solve the given LPP by simplex method. The given LPP is like this: maximize z equals to 3x1 plus 2x2 and subject to the constraints. X1 plus x2 is less than or equals to 4, x1 minus x2 is less than or equals to 2. So here two constraints they have given in the sense two slack variables we have to add it here, and we have to write the objective function in the standard form. So here s1 and s2 we are taken it as two slack variables s1 and s2, and convert the objective function in the form of a standard form, that is 3x1 plus 2x2. Here since we have taken two objective function, two slack variables are here, so it is 0 into s1 plus 0 into s2 is added for the objective function, and now inequality is replaced by equal to by taking the addition of these slack variables. So we will get x1 plus x2 plus s1 plus 0 into s2, that is equals to 4, and x1 minus x2 plus 0 into s1 plus s2 is equals to 2, and these slack variables s1 and s2 they are added for the objective function also with the coefficient 0 into s1 plus 0 into s2. I assume that x1 x2 equals to 0. You will get the initial basic visible solution as s1 equals to 4 and s2 equals to 2. These are the initial basic feasible solutions. Now what we are doing is we are writing all the values in your initial matrix, that is known as a simplex table. So here Cj, at the top you have to write the objective function coefficient. Here the objective function coefficient is 3, x1 coefficient is 3, x2 coefficient is 2, x3 is not there, so it is leave it, and s1 coefficient is 0, s2 coefficient is 0. Okay, basis, you have got the initial basic feasible solution for s1 and s2. The coefficient of s1 and s2 present in your objective function, here 0 0, so write it as 0 0. The value of s1 and s2 in your initial basic feasible solution, it is 4 2. Write it as 4 2. The remaining values are nothing but your equation coefficients. So write the coefficient. The first equation is first row, second equation is second row. The x1 coefficient is 1, x2 is 1, s1 is 1, s2 is 0. Similar to the second equation, 1 minus 1 0 1. Okay, this is the data we have mentioned in our initial table. Now now what you have to do is you have to find out zj value. In order to calculate the zj value, zj is nothing but summation of cb into xb, that is nothing but zj. So cb 0 into 4 plus 0 into 2, that is 0. 0 into 1 plus 0 into 1, so it is 0. 0 into 1 plus 0 into minus 1, 0. 0 into 1 plus 0 into 0, 0. 0 into 0 plus 0 into 1, 0. Okay. Now next one is zj minus cj. 0 first value leave it blank, second value 0 minus 3, it is minus 3, 0 minus 2, it is minus 2, 0 minus 0, it is 0, 0 minus 0 is 0. Now you have to check the condition whether all the zj values, zj minus cj values, they are positive or negative. If it is positive, no need to go further. If any one of the value of zj minus cj, if it is negative, then we have to proceed further. Here the negative value is highest negative value is minus 3. Select this column. This column is belonging to x1, so here it is xb divided by x1 divided. So xb is 4, 4 by 1 it is 4, and next one is 2 by 1, 2 by 1, so it is 2. The minimum value is nothing but this row and this column, they are coinciding at 1. Mention this as the key element. Okay, now next we have to check whether the key element is unity or not. Already here it is unity. If it is other than unity, you have to divide that throughout row by that number and make the key element as unity. Next step is you have to calculate the entering value and the leaving value. Here already key element is 1, so this becomes the entering value and this becomes the leaving value, leaving variable or leaving value also we can call. Now what you have to do is redraw the table once again. Since already this key element is 1, in the sense this next row will not change as it is, it will be maintained as it is now. Entering variable is x1, so s2 will be replaced by x1 now. x2 is replaced by x1, and the coefficient of x1 present in our objective function is written here, that is 3. The remaining values you will write as it is 2, 1, minus 1, 0, 1. Okay. Now next step is above that key element whether the element is 0 or not. If it is not 0, we have to make it as 0 by taking the row transformations. Let us name this as R1, R2, and the next row R3, R4. Now we are writing the transformation for R3. R3 changes to R1 minus R2. R3 changes to R1 minus R2. Go for the subtraction now. R1 minus R2. So S1 keep it as it is. This coefficient is also as it is. Only subtraction started from this. So R1 minus R2 you are doing. 4 minus 2 it is 2. 1 minus 1 it is 0. 1 minus of minus 1 it is 2. 1 minus 0 1. 1 0 minus 1 minus 1. Okay. Again calculate ZJ. Since the first row is multiple of 0, leave it. So Cj is again the same formula. Summation of Cb into Xb. 0 into 2 plus 3 into 2. Like this. 6. 0 into 0 plus 3 into 1. 3. So 3 into minus 1. So it is minus 3. 3 into 0, 0. 3 into 1, 3. Zj minus Cj. First element leave it blank. 3 minus 3 it is 0. Minus 3 minus 2. So it is minus 5. 0 minus 0, 0. 3 minus 0 is 3. Again you got the negative value. Zj minus Cj, it containing one element has a negative value. So again once again you have to process the step. So select that column. That column is belonging to x2. So you have to divide xb divided by x2. xb divided by x2 in the sense this is your second table now. This table xb is 2 2 and x2 is 2 minus 1. So 2 divided by 2 it is 1 and 2 by minus 1 it is negative. Whenever you are getting the negative you can delete this one. No need to consider the negative value. This row and this column they are coinciding at a point of 2. So that 2 is known as a key element. Here the entering variable is x2 for the next table. Okay. Now the next step is R5, R6. Since the key element is not unique, you have to divide R5. R5 changes as R3 divided by 2. Throughout you divide by 2, you will get the key element as 1. And here the living variable is S1. S1 is replaced by X2. So write the X2 and the coefficient of X2 present in your objective function, that is 2. Okay. And here the below that row x1 as it is and its coefficient is also as it is, that is 3. Now since we are dividing throughout by 2, so 2 by 2 is 1, 0. Here it is 1, 1 by 2 minus half. Below that key element, already you made the key element as 1. Now you have to make this element as 0. So for that the transformation you are writing R6 changes to R4 plus R5. When you add these two rows, automatically this element becomes 0. So what it will become? 2 plus 1, 3. 1 plus 0, it is 1. Minus 1 plus 1, 0. 0 plus half, 1 by 2. 1 plus 1 by 2, it is 1 by 2. Once again calculate Zj value. Zj is summation of Cb into Xb. 2 into 1 plus 3 into 3. 2 ones are 2 plus 9. So it is 11. It is 3. Next it is 2. 2 into 2, 1 by 2, it is 1. 3 into 1 by 2. So it is 1 plus 3 by 2. So it is 7 by 2. Plus next one is minus 1 plus 3 by 2. So it is 1 by 2. Get the value of Zj minus Cj. First blank. 3 minus 3. 3 will be at the top. Okay. 3 minus 3 it is 0. 2 minus 2 is 0. 7 by 2 minus 0 it is 7 by 2. 1 by 2 minus 0, 1 by 2. So all the value of Zj minus Cj, they are positive. Now no need to move further. Write the conclusion. Since all the values of Zj minus Cj is positive, we have reached the optimality, and the solution, the feasible solution, we can give it as x1 equals to 3 and x2 equals to 1. We can also verify, and the objective value maximize z equals to, this will be the objective values, maximize z equals to 11. We can also cross verify it by substituting the values of x1 and x2 in your objective function. Objective function they have given maximize z equals to, the objective function is 3x1 plus 2x2, and we got the, by the table maximize z equals to 11 we got. So we can verify it, and we got x1 value as 3 and x2 is 1. We will verify this. So here it is 11. This is equals to 3 into x1 is 3 into 3 plus 2 into 1. So it is 9 plus 2, that is equals to 11. So whatever the problem we have solved, that is correct.